We propose Protect, an eyes-free pointing technique for out-of-view menu interactions. In VR, menu items can be placed on a celestial sphere outside the user's field of view. Protect enables efficient and accurate menu interaction without the need to look by leveraging rapid row pointing through proprioception and precise adjustment with tactile exploration.
We present Quad Stretcher, a forearm-worn skin stretch display for immersive bare-hand interaction in AR and VR. 4 stretching units can contract, expand, or pose-independent control. A stimuli rendering algorithm was employed to translate the real-time 3D force vector into the control signal. In a comparative evaluation with a baseline technique, Quad Stretcher demonstrated heightened sense of realism in expressing force vectors during 3DOF interactions.
It is challenging to rotate an object in VR. Users must repeatedly move their arms and wrists. We introduced the rollable in-hand VR controller that can be rolled in each hand. First, we investigated the effects of form factors, and found that a 5 cm ball was the most effective. Next, we evaluated a rollable controller on bimanual 3D assembly tasks. The rollable in-hand controller showed a significantly faster than the VR controllers for tasks involving frequent rotations.
We present Lattice Menu, a gaze-controlled marking menu that utilizes lattice of visual anchors for stable menu selection. Users who know the location of the desired item can leverage target-assisted gaze gestures. The proposed technique shows remarkably low error rates and fast menu selection time. Users can stably and quickly trigger hands-free commands with Lattice Menu.
Making speech gestures or artificial agents is not trivial. Keyframe animation or motion capture give high-quality motion but high production cost at the same time. Automatic gesture generation is a cheap solution, but its quality is not satisfactory yet. We propose SG Toolkit, a gesture authoring toolkit based on neural generative model, supporting fine-level pose controls and coarse-level style controls.
Welcome to the mall. Our mall is the largest shopping mall with over 250 shops, 8-screen Cineplex, and plenty of gourmet cafes and restaurants.
We propose Through Hand, a novel 2D tactile interaction that enables users with visual impairments to interact with multiple dynamic objects in real time. The implementation uses a shape-changing display. A finger of the dominant hand can be used to touch the back of the non-dominant hand to interact with the objects. A study with users with visual impairments showed that Through Hand successfully provides a real-time 2D interaction through the tactile channel along with an enjoyable gaming experience.
We propose At a Touch, a novel, precise, and robust sensing technique to detect fingertip touches for handheld controllers in VR system. At a Touch leverage electromagnetically coupled impedance of an antenna and the human fingers. A loop formation of the fingers changes the coupled impedance and subsequently changes the return loss of the antenna. Through experiments and computer simulations, we developed the prototype controller to significantly revise return loss when fingers are closed.
We present Heterogeneous Stroke, a design concept that uses unique vibration cues to help users clearly recognize the spatial-temporal tactile patterns on the wrist. And due to the narrow skin area, frequent confusion can occur between tactors. And through one heterogeneous stroke, confusion between tactors can be reduced. We designed 4 unique vibrations to implement heterogeneous stroke.